Hi, David Hilderman here. We know a few things with reasonable certainty regarding carbon dioxide on Earth. World annual carbon dioxide emissions. This is the amount in megatons per year from all human sources. And we know the measured atmospheric carbon dioxide levels as taken from a mountain in Hawaii. This is shown by the red line. The second line shows the trend expected from fossil fuel burning. This is what the red line would be if the Earth didn't increase the amount absorbed when levels increased. I got this from the World Meteorological Organization website. The difference between the lines indicate additional CO2 absorption that is happening as a result of the increased levels. Why does this increased absorption happen? It is all because of increased plant growth. If absorption rates didn't increase with increased carbon dioxide levels, the black line is what the measurements would be. Here are some simplified terms going forward. Plants will be used to describe all photosynthetic organisms. They use or absorb carbon dioxide and are the carbon or carbon dioxide sinks on Earth. Animals will be used to describe all aerobic organisms. They create carbon dioxide and create the natural carbon dioxide emissions on Earth. A source will be used to describe anything that adds carbon dioxide to the Earth. This includes animals and man-made activities. A sink will be used to describe anything that removes carbon dioxide from the atmosphere. Ultimately, this is all from plant growth. Here is a simple model to describe the Earth's atmospheric carbon dioxide. The water depth is like the atmospheric level of carbon dioxide. Water entering this pipe is like carbon dioxide entering the atmosphere. It's the carbon dioxide source. Water leaving this pipe is like carbon dioxide leaving the atmosphere due to it being used by plants. Here is a model of the Earth's atmosphere with the addition of fossil fuel burning and ignoring natural carbon dioxide sources and sinks. If you plug this pipe and add water through this pipe, water will rise, right? Just like pouring water into a bucket. If we ignore natural caused carbon dioxide sources and sinks and only looked at carbon dioxide emissions from fossil fuels, this would give us the trend expected from fossil fuel burning that the World Meteorological Organization provided. This shows annual carbon dioxide emissions in megatons per year from 1960 until 2020. This is the same period as the measurements from Hawaii. It went from 9.3 thousand megatons in 1960 to a peak of 36,000 megatons in 2019. The COVID pandemic caused slight reductions in emissions in 2020. If we accumulate the emissions, we get this graph. They accumulate to 1.3 trillion tons of carbon dioxide from 1960 until 2020. Here's the graph from the World Meteorological Organization and my graph of accumulated human emissions. By using the ratio of deltas over the period of 1960 to 2000 between the expected trend from fossil fuel burning and the accumulated emissions, we calculate that an increase of 7,862 megatons of carbon dioxide in the atmosphere increases the atmospheric levels by 1 part per million. When taking numbers of the graph from the World Meteorological Organization and comparing it to values calculated from the accumulated emissions, the deviation worked out to be less than 0.5%. Scientists estimate that there are 750 gigatons of natural carbon dioxide emissions per year. Before burning fossil fuels, carbon dioxide emissions and sinks were equal, and as a result, the atmospheric carbon dioxide levels remained constant at about 280 parts per million. Let's look at the model again in this light. 750 gigatons natural carbon dioxide emissions entered the atmosphere every year. At the same time, 750 gigatons of carbon dioxide were absorbed by plants every year. Atmospheric carbon dioxide remained at a constant level of 280 parts per million. Let's add human emissions to the model. Let's keep the water flow constant at 750 gigatons per year in the first upper pipe to model naturally created carbon dioxide emissions. Let's add a second upper pipe to represent human-caused emissions. Since we have been burning fossil fuels, it is like a hose has been attached to that second pipe, and we have been continually turning the hose up. The carbon dioxide levels are rising, and as a result, the carbon dioxide leaving the atmosphere is doing so at increasing rates due to increasing plant growth. Here's the data that we have to get started with the model. Measured carbon dioxide levels in parts per million from 1960 until 2020. Man-made carbon dioxide emissions from 1960 to 2020. The amount of natural emissions per year, 750 gigatons. The amount of carbon dioxide required to increase atmospheric carbon dioxide by 1 part per million, 7,862 megatons. Here's how the model works that I made. Total annual carbon dioxide emissions are accumulated starting with an initial amount. This is the first variable to be adjusted and simulates the starting water level in the tank. Let's call that variable A. When accumulating, the previous year's accumulated value is multiplied by a number that is less than 1 before adding to the emissions from the current year. This makes emission sink rates a function of the atmospheric carbon dioxide levels, just like the rate of flow out the lower pipe is a function of water level. Let's call that variable B. An example of how the equation is set up in a spreadsheet is shown. This accumulated value is divided by 7,862, which is the emissions to atmospheric parts per million conversion. The resulting values are shifted by the appropriate amount to allow the initial value to equal the measured carbon dioxide in 1960. I then plot the resulting values along with actual carbon dioxide levels in parts per million and adjust A and B variables to get the best fit. Here's the graph again from the World Meteorological Organization along with my calculated and modeled results. As I said before, the trend line and the calculated carbon dioxide levels without land and ocean sink plots are identical within 0.5%. The actual measured carbon dioxide levels are plotted over the modeled levels. Both A and B variables were adjusted until the best possible fit was found. The final results came out much better than I expected. By adjusting variables A and B, I was able to match the modeled atmospheric carbon dioxide levels extremely accurately, within 1.5%. This is a plot of world carbon sinks versus atmospheric carbon dioxide levels as taken from model results. Plant growth, as represented by world carbon sinks, is linearly proportional to atmospheric carbon dioxide levels. I would expect this same linear range to hold true from about 250 to 800 parts per million. It is interesting that I was able to match actual with model so well using a linear relationship. Not only does plant growth rate increase on Earth with increased carbon dioxide levels, but also leaf cover increases. And this leaf cover takes time to accumulate, and yet the relationship still worked out as linear. On the Earth, plants went from converting 755 gigatons to 768 gigatons of carbon dioxide per year into plant biomass. This is an increase of 13 gigatons per year. Let's see how the model works with some alternate scenarios. If all human emissions stopped in 1960 going forward, the model shows that atmospheric levels would settle to a constant level of 286 parts per million. This is surprisingly close to 280 parts per million, which is what carbon dioxide levels were before human emissions from burning fossil fuels. Let's run the model with no human emissions, but having a volcanic event that adds 400 gigatons per year for 10 years, then back to just natural emissions after that. As you can see, the atmospheric carbon dioxide rises rapidly during the volcanic activity, but then drops back to pre-volcanic levels in only 200 years. I believe that things would happen somewhat like this. However, the increased carbon sinks that we see on Earth right now are due to increased plant growth and an increase in plants. With an abrupt addition of carbon dioxide like this, it would take a while for leaf cover to increase before carbon dioxide sinks would increase to cause the level to drop. Also, a volcanic event would spew out sulfur dioxide and ash, which would likely kill a lot of plants and potentially block the sun, which could reduce photosynthesis for a while before increasing. This could result in something possibly like this. Going further into the future, carbon dioxide levels would go down to pre-industrial levels, but there would be much more things influencing the trajectory. Fundamentals of carbon dioxide on Earth. Carbon dioxide and water are the raw materials for plant growth. This is what plants are made of. Increasing atmospheric carbon dioxide increases plant growth, just as reducing carbon dioxide reduces plant growth. Using the analogy of a water tank representing atmospheric carbon dioxide on Earth, let's look at the Earth before life began. Using the water tank analogy to represent the history of carbon dioxide on Earth, I have made this graphic. It's a 2.9 meter diameter, 100 meter high cylinder beside a 1.7 meter tall person. When full, this represents what scientists estimate is the 70% minimum that carbon dioxide comprised of the Earth's atmosphere before life on Earth, and it would have stayed that way had life not come along. The first life form on Earth were plants in the ocean. The best guess is that they first appeared 4.6 billion years ago. They used carbon dioxide to create plant biomass and oxygen. Shortly after plants, aerobic organisms, including bacteria, evolved that used the oxygen and created carbon dioxide. Carbon dioxide and dissolved calcium was converted to calcium carbonate by both plants and animals. Limestone is made from this calcium carbonate. This continued to use up the carbon dioxide that was originally there from the start of the Earth. When plants first evolved to come on land, the plants and shellfish had used up most of the carbon dioxide. Only 1 meter was left in the tank. 0.7% of the atmosphere was now carbon dioxide. Life used carbon dioxide faster than it was being made, so it continued to drop in levels until there was only 40 millimeters left in the tank. So it went from 100 meters at the start of life on Earth to 40 millimeters, and it stayed there for millions of years. Instead of having a nearly limitless supply, plants now only had what was being created by animals on Earth. This is my understanding of the best estimation of the history of carbon dioxide, going back 600 million years. It goes back to the earliest fossil records when life first came out of the oceans onto land. Carbon dioxide would continually go down as it was used by life. Volcanic activity would inject carbon dioxide into the system to bring up carbon dioxide levels, but as you can see, it always comes back down to a minimum of around 280 parts per million, or 0.028%, which is the same as it was before we started burning fossil fuels. Let's take a look going into the future using the model, this time taking the nightmare scenario for an environmentalist. This graph shows what I will use as human-caused carbon dioxide emissions to predict future atmospheric carbon dioxide levels. Statistica.com predicts that if we go business as usual, we will be emitting 43,000 megatons of carbon dioxide annually in 2050. I'm going to use numbers that I think would reflect successful industrialization of India and Africa. Carbon dioxide emission rates would increase much faster than Statistica predicts, reaching 48,000 megatons by 2050 and continuing to rise at that rate until a peak of 59,000 megatons per year in 2080. And then I'm going to keep that level going forward. This is what it came out with. Even with the extremely high annual emissions, the atmospheric levels just reached 700 parts per million. And this is going all the way to the year 2200. Increased atmospheric carbon dioxide increases plant growth rates. As the carbon dioxide levels increase in the atmosphere, plant growth rates increase and eventually stabilize the carbon dioxide emissions. From the data that made the previous slide, I calculated annual plant growth rates, or carbon dioxide absorption rates caused by human emissions. When we increase carbon dioxide emissions, the atmospheric levels increase. Increased atmospheric levels increases plant growth rates, which increases the rates that plants use the carbon dioxide that we are adding to the atmosphere. Given enough time, plant growth will increase to the point where it will absorb all the carbon dioxide emissions from human activities. All that needs to happen for this to occur is the atmospheric levels need to rise in order for plant growth rates to increase. This is all based on my model. Here's some information that I feel supports my theory that plant growth rates will rise to accommodate increased carbon dioxide emissions. I think it probably started in about 2008 and continued on until 2011 or 2012, there was a white pine beetle infestation in the forests of BC. This white pine beetle killed 20 million hectares of forests in British Columbia. The government wanted to know, okay, man, this really caused a loss to BC forests. How long was it going to take for all the board feed that was lost from the white pine beetle to come back? The people doing the study came up with quite a surprising conclusion. All those lost board feed would be replenished by the year 2020. And the reason? Because every year, due to rising carbon dioxide levels, the BC forests were increasing their growth rates by 1 to 3% per year. Some say that increased carbon dioxide is plant fertilizer. I don't think that is accurate. A fertilizer is a trace element that makes something grow faster. Carbon dioxide is more like a raw material for plant growth. It, along with water, becomes the plant. It isn't even accurate to call it plant food. When we think of food, we think of something that gives us energy to live. When plants take in carbon dioxide, it is used to build more plant matter, not just to live. We only hear from the media how everything is getting worse on Earth. This study was based on satellite data. From 1982 until 2015, the Earth gained 18 million square kilometers of leaf cover. This is the equivalent to adding all the plants of continental United States to the Earth twice. 350.org is named after their objective of getting atmospheric levels to 350 parts per million. Measured carbon dioxide levels increased by 62 parts per million during the time of this study that shows this leaf cover increase. The amount that the Earth has changed in atmospheric levels from the time it was 350 parts per million until now is about the same. It's actually a little more. It actually changed more. If 350.org had their way, those 18 million square kilometers of leaf cover that was gained as a result of increased atmospheric carbon dioxide levels would die. The current leaf cover of the Earth needs higher carbon dioxide levels in order to survive. Let's have another look at historical carbon dioxide levels. Past large increases in carbon dioxide were likely caused by volcanic activity. This activity would have been immense and highly destructive. Whenever carbon dioxide increases, plants would increase growth and use that carbon dioxide up until an equilibrium occurred, reaching levels similar to before we started burning fossil fuels. And again, when I say an equilibrium, that means that carbon dioxide being created by breathing animals and bacteria, whatever's naturally creating carbon dioxide on the Earth, plants would be using that same amount. They no longer have this vast amount of carbon dioxide that was there from the start of the Earth. Burning fossil fuels increases carbon dioxide without the destruction of volcanoes. Our current levels of carbon dioxide are higher than they have been in 5 million years, and plant growth is also higher than it has been in 5 million years. So, ultimately, what are my conclusions? Carbon dioxide levels are higher today than they have been in 5 million years, and because of these high levels, plant growth rates are higher now than they have been in 5 million years. Carbon dioxide and water is what plants are made of. Saying that carbon dioxide is a pollutant is equivalent to saying that water is a pollutant. Prior to burning fossil fuels, plants were limited in their growth rates by the carbon dioxide created by breathing organisms. Burning fossil fuels is increasing life on Earth. If we allow carbon dioxide levels to continue to rise without restrictions, plant growth rates will rise to accommodate the increased levels in the Earth. All animals and plants will have the benefit of significantly increased plant growth. It is reprehensible that these facts regarding the positive effects of carbon dioxide are being hid from us. The idea that my analysis is new is not possible. Why is it that we haven't known this? Why is this not as well known as the idea that carbon dioxide is a greenhouse gas and is causing temperatures to rise? The fact that carbon dioxide levels rising is increasing plant growth is a very significant thing to our Earth. 2 times the plants of all United States has been added to the Earth from 1982 to 2015. That is a massive amount of leaf cover in plants. Why is it that we don't know this? Why is our media not reporting on this? That's the end of my presentation of my little simple model.